AWGs, or Arbitrary Waveform Generators, generators that allow you to arbitrarily create and generate the signal you want to output. This is accomplished by using digital to analog converter technology, enabling you to define a waveform in memory and sequencing it through a DAC system with a precision clock, and then outputting it as an analog waveform, as we see in this simple block diagram. AWG specifications can be segmented into three main categories: sample rate, memory depth, and vertical resolution. This topic will cover vertical resolution. Vertical resolution is expressed in voltage output precision of the waveform, expressed in binary word width delivered to the digital to analog converter. Higher bit AWGs result in greater vertical resolution, but the trade-off is sampling speed. 8-bit to 16-bit DACs are commercially available today. An example would be an 8-bit DAC at a 1 volt peak-to-peak amplitude, or 1 volt divided by 256 will give you a 4 millivolt of resolution, whereas a 10-bit DAC system, or 1 volt divided by 1024, will give you closer to 1 millivolts of resolution. Here we'll go ahead and create a waveform using the AWG Waveform Creation tool and show you the differences between using an 8-bit and 10-bit DAC system. So here we're creating a ramp waveform to symbolize basically a DAC system. And here you see 10 points gives you a stair-step effect, so that would be a very low resolution DAC. So if we change this waveform length to represent closer to what an 8-bit DAC would be, or 256 levels, or 0 to 255, would represent an 8-bit DAC system. So we'll go ahead and create this 8-bit DAC ramp with 256 levels and display it in the AWG. So now we've created an 8-bit DAC ramp waveform. So we'll go ahead and create a 10-bit DAC waveform now, using the same characteristics, except instead of 256 levels, we'll change this to 1024, or 0 to 1023. And we'll go ahead and name this 10-bit DAC system. You can see that the granularity of the waveform is a little bit finer using the 10-bit DAC. So now we have a 8-bit DAC waveform and a 10-bit DAC waveform that we created. So let's look at the 8-bit DAC waveform in a little bit better detail. As you can see, we can select either 8-bit DAC or 10-bit DAC system with this AWG. So if we look at a tabular format, we can see the time values, and we can also see the vertical amplitude values. If we take the first 2 points and look at the difference between them, we can see that what the vertical resolution actually is. So if we take 0.5, subtract 0.496063, we can see that vertical resolution for the DAC system is at close to 4 millivolts. So now we can do the same thing with our 10-bit DAC waveform. So we'll go ahead and load in the 10-bit DAC. We'll go ahead and change our setting to 10 bits. And now we'll go ahead and look at it in a tabular format so that we can look at the differences between the two vertical levels. Here we take 0.5, subtract 4.4990215, and you can see with the 1024 points that we get closer to 1 millivolts of resolution, representing a 10-bit DAC system. So this is a good example of the differences between an 8-bit DAC and a 10-bit DAC system in an arbitrary waveform